This is problem 11.4, and we are asked to find the moments at B and C.
As you can see from the diagram, we have pins at A, B, C, and D where it's walls. We have triangular loads between C and D and A and B, and a rectangular load of 4 kilonewtons per meter between B and C. These are the rotations we expect throughout the structure. However, for the problem, we assumed all positive rotations. This is the slope deflection matrix that we're going to be using. However, we haven't written it all down because it's too long. So for section AB, this is the matrix that we're going to use. We have deflections at A and B equal to 0, and we're concerned with moments at A and B and the rotations at A and B. So writing the whole matrix down, we get these equations, and since rotation at the moments at MBA and MBC are going to be equal, we have to equate these two equations where we do later. So then we have to add on the fixed end moments for points A and B, which we get from the back of the book, where W is 4 kilonewtons for us and length is 12 meters. Now we go on to section BC, where we write down the equations from the matrix for moments from between B and C, and we know that it's equal to the moment MBA. We do the same for the point C, where moment C is equal to moment CB is equal to moment CD, and we do the same for section CD, where moment CD is equal to moment CB. Just write all this out using the matrix. Moment at D is going to be equal to 0. And then finally, to get moments at B, we equated moment BA and moment BC and ended up with this equation. Of course, we assumed EI is constant. Did the same for moment C, where CB is equal to CD, and we get equations for M, theta B, theta C, theta D. MA and MD are going to remain the same because we had them equal to 0. So we wrote down those 4 equations in a matrix form, with A being the constants and B being theta A to theta D. F is the fixed end moments. So to find theta A, theta B, theta C, and theta D, we use A inverse in an F, and we did this using MATLAB, from which we got these values. Plugging these values back into these equations, we can get moments at A, B, C, and D.